Hi everyone, my name is Craciunesc. I'm a lead platform engineer at World Wizards. This talk will be on what it says on the tin, AWS Cognito Serverless Authentication System. A bit of cheeky PR or marketing. Our goal is to make financial advice affordable and accessible to everyone. I know it's bold. We put a lot of effort in making that happening. The way we go about it, we create applications that automate giving financial advice. We have an application called Turo for advisors aimed at financial companies to automate their process of giving financial advice. It's completely regulated, FCA regulated, as in Financial Conduct Authority. The main one for our purpose would be Maiva, which is again fully UK regulated digital financial advisor. It has a chatbot interface. If you log into it, so you can go to app.maiva.com, register with your email address. You get a bunch of to-dos, as we call them. Depending on your financial situation, they might look differently. This is from a demo app. As you go through them, you'll be presented with the chat and choices interface. This is from the to-do about buying my first house. And you are asked a bit of information, and then you can be put in contact with a mortgage advisor. Now, enough about this. Amazon Cognito. Out of curiosity, is anyone using Cognito? Or does anyone know what Cognito is?
Okay.
Cool, so that's good for me. Possibly it'll make my talk less boring. But in short, it's a serverless authentication system. Things like storing username and passwords. So you can create your web application on a mobile app, configure it to use Cognito. Cognito will issue JWT tokens, and the app can use those tokens, refresh, access ID, and these ones. It's split in two main things, user pools and identity pools. User pools is where you can go and create username and passwords, have them assigned to groups. Can create SAML federation if you want to, as in allow logins with LDAP, Azure AD, or any identity provider. Supports social logins, we'll see a slide later on. Identity pools can be used to issue a user with a bunch of AWS credentials, so he can access AWS resources, like maybe put a file to an S3 bucket, or invoke a Lambda function, or who knows what you need to do. And as a short example, we have a web app which has a file upload capability, pretty basic. The user logs into the app using SAML authentication based on his corporate credentials. He gets a token, and when he goes on click on file upload, he'll also get AWS credentials, as in the browser will get those credentials, and he will be allowed to upload the file directly to S3. It's pretty transparent to the user. Those are short-lived, few minutes. Pretty much the same thing I talked about earlier on, duplication of slides, but with fancy pictures this time, user pools, federated identities. Now, user pools, or directory for all your apps and users. What does it mean? How does it look like? This is a screenshot from the AWS console, and I'll show a bit of Terraform later on. It's not fancy, that Terraform, but anyway. So when users are created, they get an ID automatically generated by Cognito. Then you have status, confirmed or forced change password. If the user never logged in, he's in this state, forced change password. He has to set a password first, a bit of information on like updated, created. You can search users. It defaults to username, which means this ugly ID. I never managed to remember one, but you can click on this thing, get a drop-down list, and then you can search by email or phone number, if I remember correctly. Most of the time, if not every time, I search by email. Sorry. Can create groups over here, and on the left side menu, if you go into attributes, you can create, you are presented with the list of attributes like first name, last name, email address, phone number, postcode, or a bunch of default attributes. There's also a possibility to create custom attributes, and I'll talk about that a bit later on and how we use custom attributes. It does fancy things like multi-factor authentication, can be SMS, email, or application-based. Has a thing called advanced security, which I quite like it. and that only works when you use username and password authentication. If you have SAML or social logins, it's not in use because the identity is verified by the provider. It's not verified by Cognito. Again, a screenshot from the console. You can enable it. It can detect compromised credentials. How it does it, I don't know. I searched the Amazon documentation, I wasn't able to find. Maybe I'll ask somebody from Amazon later on. And then you have this low risk, medium risk, and high risk authentication events. So it rates the user based on source IP, how often it authenticates. If you try to enter the password multiple times and it failed, and can take decisions, can say, okay, this time require MFA or block it. Also supports username and password, IP access lists, as in whitelist or blocklist, which is pretty cool. And then once this is enabled, you get an audit trail of user logins with the way they are rated, high, medium, or low. It also has a built-in UI. So if your Cognito-enabled application, you don't have to write your own UI. You can use the built-in one. Also, there's the possibility to write your own application, your own UI, sorry, on top of AWS Amplify. And we'll talk about Amplify a bit later on. It's fully customizable. You can customize the hosted UI. This is how it looks for us on Churro for Advisors. It's pretty basic. You get a button for single sign-on, then username and password, reset password, and sign in. Click on those. But what you see here is done only through CSS configs that we uploaded in Cognito in Amazon. Quite straightforward, easy. Give it some pictures, and that's it. Besides this, Cognito has what is called Lambda triggers, or in short, triggers. The goals of these ones is to customize the user authentication flow. Let's say you have users, you allow them to pre-sign up. Then depending on their email address, you can take additional actions by using pre-sign up Lambda trigger, as it says here, or if the user logs in with an email address ending with gmail.com and you want that user to be in a group, give it a specific access. You can use a pre-token generation Lambda trigger, add him to the group. Then the token will be generated and will contain user group membership into the token, and that can be used by the app later on to give him access to parts of the application where it needs to use. This is how it looks, a custom authentication flow. Again, it's mainly screenshots from Amazon documentation. When we started with it, there weren't many blog posts, many articles. User logs in, then there's a sequence of events happening, Lambda triggers. Based on their outputs, a decision is taken. Should the user provide maybe 2FA, a code received via SMS or a mobile app? Another screenshot on how Lambda triggers can be set in the Cognito UI. If you click on any of these drop-downs, you'll be presented with a long list of Lambdas available in your account. It's not the best way to set them up. It works. I prefer Terraform because it's easier. Just give it a name and it sets it in there. I was mentioning earlier on that Cognito supports plenty or loads of providers. You can log in with Amazon, social logins, SAML, LDAP-based OpenID, custom providers. What we use at Wealth Wizards is Cognito user pools, where users can log in with username and password, or SAML. And our SAML provider is Azure AD. Quick talk about SAML. It's a mechanism or a protocol to exchange authentication and authorization messages, mainly between identity provider and the service provider. Identity provider is the place where you validate the identity of the user. Service provider is the app itself. When Cognito is configured to use SAML, the user goes to hosted UI, and the hosted UI determines which provider should user be redirected to. Will be redirected to log into the correct provider. Login will take place. Once he's been authenticated, the IDP will post back the SAML assertion with information he's been configured to do. Now, the question is, why are we using Cognito at Wealth Wizards? This is a very summarized version of a basic React app with an API and a storage layer for storing usernames and passwords. It was happy days. It worked for us quite well for a period of time. But then what if you get more users into your application? Then you might have to scale your API layer, which might be fine if you get your capacity planning right or automation right. But about scaling the storage layer, more complexity. SAML federation, maybe I need to write new code. I have more added weight into my custom authentication system. What about Facebook login or Twitter or Stack Exchange one day, Stack Overflow? What about MFA? I don't even know how to secure those MFA tokens. That's a whole host of things that I have to deal with, and I don't know how to do it. So that's why Cognito made sense for us. Plus, I don't have to worry about how does it scale, is it secure, how are passwords stored, do I salt them, do I hash them, what's this thing, bcrypt, is it still a thing? Oh, I don't know. I let Amazon to deal with all that complexity, and I focus on writing my application. Now, in our apps, we use AWS Amplify, which is a Node.js module, npm install, and that's it. It's easy to configure, quite straightforward. You give it a few settings like Cognito region, pool ID, web client ID. So in Cognito, you're going to create a web client. A pool can talk to multiple web applications, and each one can have its own ID and secret, which are passed down to the application. So the app will use that ID and secret to authenticate itself against Cognito. And auth settings, so we can have SAML logins. When it comes to Terraform, straightforward, to be honest, a bunch of resources. That's the module, a snippet from the module we've written to deploy Cognito user pools. We have loads of tenants, each one with its own environment. For each one, we create a user pool with his own settings. To create it, we copy-paste what you see on the screen. Again, it's a trimmed-down version. But basically, what we care about is groups configuration, what groups the application should have, what is my SAML config, as in who are my identity providers that allow users to log into the app, and give Cognito the XML metadata file, and then the module itself. We call this a building block most of the time. It's copy-paste, find and replace by name, Terraform, plan, apply, and that's it. Now, in SAML token claims, the one that we care most for our application, so it might be different from one app to another, is the role claim, which is actually a custom attribute in Cognito. It doesn't exist by default, so we have to create it and say it's custom, and also set it as writable. By default, they are not set as writable. And that role, that claim, is populated in Azure Active Directory. When the user logs in, our corporate identity system is based on Azure Active Directory. Users are sent there, they are logged in, and they are associated to roles in Azure AD, and those roles are populated in the claim. And later on, there will be a Lambda function which will map those roles to Cognito groups. That's pre-token generation. Then the token is generated, or group membership, and then he will get access later on when he actually starts using the application. The process is pretty fast. The user can't tell how much time it takes, less than a second. I haven't timed it, to be honest, but it was fast enough. Now, how to configure roles in Azure AD? It's a bit of a process. Microsoft offers something called Graph AD. So basically, you'd go into Azure Active Directory in portal.azure.com. You create an enterprise application. It's similar to creating an app in Google, for example. There's nothing special about it. It has a name, it has a bunch of unique properties like IDs, and then in Graph Explorer API, when you log in for the first time with your admin account, you'll be asked to allow Graph Explorer to perform some actions on your behalf. Yes, click yes, yes, yes. And then you go to the beta API, very Microsofty, I would say, to patch the application in Azure AD, so it can have additional roles besides the default ones, the default being default end user. But I want a role with a name that matches my group in Cognito. I patch that app, and they will be available. So this would be how the JSON payload looks like when I patch the app. And later on, and here, these are my users. I can also use security groups or distribution groups, if I'm not wrong. And they can be assigned to roles. And once this is done, the user will have those roles in the SAML claim. And that's great. But once the claims have been populated and the user or the SAML assertion is posted back to the UI, then Cognito still hasn't added the user into the groups. So we wrote a pre-token generation trigger, a Lambda function, which matches claims with Cognito groups, keeps them in sync all the time with every login. Besides that, we also wrote a user migration trigger. This is how it's called. The reason for doing that is because we had an in-house developed authentication system, and we had to move users of that system to Cognito. What we did, we took an export of usernames, mainly first name, last name, email address, put it in a file, S3 bucket, encrypted with some encryption keys, and this is just a snippet in here. When the user logs in for the first time, once the application has been migrated to use Cognito, this trigger will run. We'll look at the user email address, look it up in the file. If it matches, then we'll send an email to the user saying, hey, you have to set a new password, because it's the first time we'll log into this app after Cognito has been enabled. And that was a decision we took to force users changing their passwords. Now, user migration trigger, once has been enabled on the Cognito user pool, it also runs if the users go in the UI and say, I forgot my password. And if the first flow is triggered, so we had to cater for both situations to determine what the state the user is in. And this is a snippet showing how we deal with users clicking on forgot password. So basically it's us determining the trigger source and then invoking forgot password Cognito API, which is a Lambda function. It has a role attached to it, allowing it access to a specific user pool. And to invoke only the APIs that it needs to do. Now, this is how it works. And as you can see, this is just a screenshot of Amazon documentation. Why I've put that in there. I wanted to say how it worked for us. To be honest, it was a bit of a steep learning curve. It was a new service. We didn't know at first exactly how to use it, how to use these triggers. It took a while to understand when to use each trigger, what each one is doing. There was a lot of time spent with Amazon Docs reading them. There were not, back then, too many blog posts or articles or videos or tutorials, so this was the go-to place to learn on how to use it. There is plenty of API docs. They give loads of information, but then I don't know if so only reading this API doc, I don't know when I call admin create user what parameters are mandatory. Is it a string? Is it a number? And after all, we've discovered the SDK docs, and that's when the light bulb turned on. And boom, developers like it. I like it as well. It was easy to tell, okay, oh, this is how I use it. I can write my Lambda triggers now. I can migrate my users and do all the things. It's been great for us. Magic Link support. There is no support out of the box. One application we developed, actually Maiva, the one I was talking about earlier on, has Magic Link support. You just give it email address, you get a link, click on it, you are logged in. Amazon didn't have support back then. There was little information on the internet. We realized, okay, we can achieve this if we write our own Lambda triggers. We decided not to do it. We had the code in our own auth system. We keep using that one. Since then, they wrote a blog post. It's quite good this day, but Amazon reInvent is just around the corner. They've released loads of good things lately, pre-reInvent. Possibly they will make this even easier. So this is one place where you can use custom authentication, challenge and triggers, but it involves writing a bit of code. Now all the functions are published on Serverless application registry for everyone to use. When we started, they were not there. But anyway, it worked for us. Besides web apps, we also have a bunch of Lambda functions that do some back-end stuff. Some of them, they are hooked to Cognito. Doing that is pretty straightforward. In serverless.yaml, we use serverless framework to deploy serverless things, loads of serverless. It's fancy. You just say authorizer, Cognito user pools, reference to my authorizers in here, and that's it. I don't have to worry too much about it. It's pretty cool. Now, All in all, Cognito, I think it worked out pretty well for us. It was a steep learning curve. It took us a bit of time to get used with it. But when I think about the IT stack, there's the lower tiers like servers, storage network, cables, and whatever, operating systems, maybe some clusters and things like that. But with Cognito, I didn't have to worry about anything like that. All I had to focus on how do I migrate my users from A to B, what logic do I have to do, how do I make the user experience, which for me is all as close as possible to business logic from an authentication point of view. Even when I wrote the Lambda trigger that maps SAML claims to Cognito groups, that from my point of view is business logic, and that's when it felt that's business value, and it felt quite enjoyable for me. It was really good. And as I said earlier, don't have to worry, how does it scale? Is it safe? Is it secure? All these things. It's great. It's quite cheap, if you ask me. It worked well for us. Happy to continue using it. And with that, it is the end of my talk. Thank you for listening.